Welcome to the tutorial on step response of RC circuit. In an RC circuit, which consists of, say, the voltage source represented as Vs, a resistance R, and we have a capacitor C. The voltage across the capacitor is Vc. Say the input changes from Vi to Vf at time t is equal to 0. So when we do the analysis for this particular circuit, we say that the source voltage Vs abruptly changes from the voltage Vi to voltage Vf at time t is equal to 0. So let us analyze for each and every instant. At time t less than 0, as we know, so for a capacitor in steady state, the element acts like a open circuit. So I can consider the equivalent circuit for this, wherein I have the input voltage Vi considered, we have a resistance R, and here the circuit is open. The voltage across this I'm going to consider as Vc, and this voltage is equal to that of the input Vi, that is the source voltage Vi, because the circuit is open and the current flowing through this particular circuit is almost negligible and there is no drop across this particular resistor. Since I'm analyzing at t less than 0, I can consider Vc of 0 minus to be equal to Vi, and we know that in a capacitor the voltage does not change immediately. So the voltage across the capacitor at Vc of 0 minus is equivalent to that of Vc of 0 plus. Now let us analyze what happens at time t is equal to 0. As we just now said that the voltage across the capacitor does not change immediately, it takes some time. So at time t is equal to 0, the voltage that is there across the capacitor is going to remain at Vi, but the current that was equal to 0 in this case is now going to change. There will be some flow of current. That is because now the element capacitor is going to come into picture. So there will be some flow of current, and this flow of current is given by I is equal to the source voltage Vs minus the voltage across the capacitor divided by the resistance. I have denoted this capacitor voltage as Vc of 0 minus, which equivalents to Vc of 0 minus equal to Vc of 0 plus. So I can rewrite this expression as Vf minus Vi divided by R. Since now the value of Vs is going to be equal to Vf, because as we have seen here, the input voltage changes from Vi to Vf at t is equal to 0. Now let us analyze what happens at time t greater than 0. So at time t greater than 0, the capacitor starts charging and it charges to the peak value of the input, that is equal to Vf, and the current will drop to 0 and hence the transient will be complete. Mathematically, the expression can be given as Vc of t to be equal to Vf plus Vi minus Vf e power minus t divided by tau. Since we are talking about RC circuit, tau basically corresponds to the time constant, which is the product of R into C. So this time constant gives you the decay in the waveform. So this time constant, which is a product of R into C, will give you the variation in the charging current and the amount of the charge required depending on which parameter you will change. If you change the value of R, the charging and the discharging current will change. If you change the value of C, the amount of charge required will be changed.